Hello my dear students, in this small video we are going to derive an expression for acceleration due to gravity on the surface of earth. Okay, we are going to derive this equation G is equal to GME divided by RE square, where ME stands for mass of earth and RE stands for radius of earth. And this equation holds good for any planet. Okay, for any particular planet I should write like GMP divided by RP whole square. We'll see how to derive it. Say I consider okay, say this is earth. Okay, say mass of the earth is Me stands for mass of earth. Okay, radius of earth, let it be Re. Okay, now what we have done, we have considered a mass M on the surface of earth. We have considered a mass small letter m on the surface of earth. Okay, now according to universal law of gravitation, okay, according to universal law of gravitation, according to universal law of gravitation, what is the force between them? Okay, what is the force between this body of small letter m, okay, mass small letter m, and mass of earth? Okay, so what is the distance between this mass and this earth? Okay, mass of the earth is to be considered at the center, okay, by symmetry. So this distance would be radius of earth, correct now? So according to universal law of gravitational, force acting on that mass, okay, force acting on that mass is equal to G into m1 into m2 divided by r square. m1 into m2 divided by r square. So this is the equation. Okay, this is, I call this as equation number 1. Okay. Now according to Newton's second law, yeah, according to Newton's second law, according to Newton's second law, so we know that F is equal to mg. It is weight, correct? Now force acting on the body is equal to its weight. So this is my equation number 2. Okay. From these two equations, what I will do? So this is what I want to derive. Okay. From these two equations, I can equate these two, correct? Now, so what happens? mg is equal to, okay, from 1 and 2, mg equal to G into me into m divided by Re square. So what happened? This m and m gets cancelled. We got G is equal to Gme divided by R square. This is very simple derivation. Okay. So this is the expression for acceleration due to gravity on the surface of earth. Okay. Now we know that value of G on the surface of earth is 9.8 meter per second square. We knew this in our high school, and we have used this value of G while studying motion in straight line chapter. We have taken G is equal to 9.8 or 10. Okay. Now we'll see if we substitute the values for universal gravitational constant, mass of earth and radius of earth, whether we get to 9.8, we will check. Okay. This acceleration due to gravity varies with height, varies with depth, varies with latitude, varies with the rotation of earth. There are many factors, and we are going to study one by one. Okay, this is the first one, the basic one. Okay, let me substitute these values and we'll see what is the value of G. Okay, so G is equal to, if you know all the values, GME by R square, correct? Now GME by RE square. Okay, that is equal to, G means what? What is the value of G? 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Mass of earth is approximately, it is 6 into 10 to the power 24 kg. It is something like 5.97 into 10 to the power 24. For simplicity, I have taken just 6. Okay. Radius of earth is 6,400 kilometers. Okay, 6,400 kilometers. I'll write this as, okay, kilo means 10 to the power 3, correct now? 6,400 into 10 to the power 3 meters, or I'll write it as 6.4 into 10 to the power 6 meters. 6.4 into 10 to the power 6, because here there is one 10 to the power 3. Okay, here there is a point, I have shifted here. Okay, I got that 10 to the power 3. 10 to the power 3 into 10 to the power 3 is 10 to the power 6. Okay, Re square means 6.4 into 10 to the power 6 whole square. Okay, how do I simplify this? I'll keep it aside. Okay, how do I simplify this? This is equal to, G is equal to 6.67 into 10 to the power 11 minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 raised to 6 whole square. Okay, 6.4 into 6.4. Okay, 6.4. Okay, I think I have missed this. Where is that? Okay, 6.4 into 10 to the power 6. Okay, 6.4 square means 6.4 into 6.4, correct now? Into 10 to the power 6 whole square means 10 to the power 12, correct now? Or I'll write it as, I don't have a calculator, okay? So let me do the approximation. 6.67 into 6 divided by 6.4 into 6.4, 6.4 into 6.4, okay, into 10 to the power minus 11, 10 to the power 24, 24 minus 11 is 13, 10 to the power 13, okay. Here there is 10 to the power 12, when it goes up it becomes 10 to the power minus 12, so minus 12, correct now? So what happened? See, if you look at the numerator, 6.67 into 6 is less than 6.4 into 6.4, you can see, okay. Or if you do this calculation in calculator, or roughly they get cancelled, and you are going to get 1 into 10 to the power 1, 10 to the power 1 is 10, no? Roughly you are going to get 10 here, okay. But if you use the calculator, you are going to get some answer somewhere around 9.8 meter per second square, 9.8 meter per second square, okay. So this is how we calculate the acceleration due to gravity. Sometimes problems may come based on this formula, like say for example, radius of earth. So earth is compressed such that radius becomes half, keeping the mass constant. What will be the new acceleration due to gravity? Such questions may come, and they are very simple. So radius of earth, if you reduce it to half, what happens? In the place of RE, you have to write RE by 2 whole square, correct? RE by 2 whole square. It becomes RE square by 4. That 4 will go to the numerator. So when the so radius reduces to half, acceleration due to gravity increases 4 times. Such simple type of questions may come. So in the next class, we are going to see how the acceleration due to gravity varies, okay, with the altitude, with height. Means from the surface of earth, as you go upwards, what happens to acceleration due to gravity? That we'll see in the next class. Hope you understood this. Thank you very much.